The purpose of this video today is to introduce you to the impact testing, one of the important testing in determination of mechanical behavior of materials. We have learned previously what does it mean by toughness. So if you still remember, the toughness of metals is the toughness of metals or any kinds of materials is the ability to withstand impact. In material science and metallurgy especially, toughness is the ability of material to absorb energy and plastically deform without fracturing. So one definition of material toughness is the amount of energy per unit volume that the material can absorb before rupturing. In impact energy, the energy that is necessary to fracture a standard test piece and an impact load is a similar envelope of toughness. So toughness refers to the capacity of a material to absorb energy prior to failure, like what I have mentioned before. Its value is equal to the entire area under the stress strain curve, like what we can see in the figure here. In most cases, the area under the curve, the area under the plastic portion, the area under the elastic portion of the curve is a very small percentage of the total area, and we may ignore it in the calculation of the modulus of toughness. This is the typical stress strain curve of material, like what we have learned in a previous chapter. Stress strain curve is the behavior of material when it is subject to load, subjected to loading. In this diagram, stresses are plotted along the vertical axis, and as a result of these stresses, corresponding strain are plotted along the horizontal axis here. So when we have a ductile material like mild steel, we subject it to tensile testing, and then it will experience or passes various stages before fracture. If you still remember, the stages in a stress strain curve are proportional limit, elastic limit, yield point, ultimate stress point, and breaking point or fracture point. So what is the impact testing? The impact test is a method for evaluating the toughness on notch sensitivity of engineering materials. It is usually used to test the toughness of metals, but similar testing used for polymers, ceramic, and composite. And what is the purpose of impact testing? Impact testing, we use it to determine the material behavior at the higher deformation speed. Classical pendulum impact testing determine the impact energy absorbed by a standardized specimen up to break or fracture by measuring the height of the rise of the pendulum hammer after impact. So the purpose of an impact testing is to determine the ability of material to absorb energy during a collision. This energy may be used to determine the toughness, the impact strength, fracture resistance, impact resistance or fracture resistance of a material depending on the test that was performed and the characteristic that is to be determined. These values are important for the selection of materials that will be used in application that require the material to undergo very rapid loading process, such as in a vehicular cohesion. For single impact testing, the three most popular types of tests are the choppy V-notch testing, the choppy V-notch testing, and the isotest and tensile impact testing. And these three tests are all essential to determine the same characteristic of a material, but differ in the orientation of the test sample, which causes the sample to be stretched in a different direction, and involve a height that the weight that we know released from unknown height with colliding with the specimen in its test fixture. So as what I have mentioned before, impact testing of metals is performed to determine the impact resistance or toughness of materials by calculating the amount of energy absorbed during fracture. The impact test is performed at the various temperature to reveal or uncover any effect on the impact energy. So in this lecture, we will be discussing more on the choppy impact test and its application, choppy impact testing, and some information about the other impact testing and its application. So choppy impact test is the most commonly used mechanical testing, which is used to determine the amount of forces, that are absorbed by materials when it reaches the point of fracture. And this amount of energy gives the analysis of the notch hardness of a material. So this is the experimental setup for both choppy and horizontal impact testing. The choppy impact testing, also known as the choppy V-notch testing, is a high strain rate testing that involves striking standard notch specimen, like what we can see here, with a controlled weight, pendulum or hammer, swung from a set height. The impact testing helps to measure the amount of energy absorbed by the specimen during a fracture, the amount of energy absorbed during fracture. So the test principle is quite straightforward. The energy necessary to fracture the test piece is directly calculated from the difference in initial and final height of the swinging pendulum. To provide a control over the fracture process, stress concentrating notch is machined into the side of the sample that is subject to a maximum tensile stress, like what we can see in the figure here. So a choppy testing shows whether a metal can be classified as being either brittle or ductile. This is particularly useful for specimens such as a metal specimen such as ferritic steels that show a ductile to a brittle transition, ductile to brittle transition, or DBBT. This is like what we have discussed previously. So this is particularly useful. Choppy test is useful for a metal specimen like a ferritic steel that show a ductile to brittle transition with a decreasing temperature. Brittle metal will absorb a small amount of energy when impact tested, and a tough ductile metal absorbs a large amount of energy, like what we can see in the figure here. We can see the differences between brittle fracture and ductile fracture at a different temperature. So the appearance of a fracture surface also gives information about the type of a fracture that occurred. A brittle fracture is bright and crystalline. The appearance in terms of the appearance of a fracture surface. On the other hand, a brittle fracture, a ductile fracture is quite dull and fibrous. So for isotope impact testing, the test apparatus and specimens designed are very similar to CHAPI impact testing with some notable differences, including the orientation of the specimen, which is clamped into the apparatus vertically with the notch facing toward the pendulum. The pendulum then impacts the sample at the specified area above the notch, like what we can see here. So this is the difference between the CHAPI impact testing and the isotope impact testing. In addition to that, one of the main differences from a CHAPI impact is that isotope impact testing can be performed on either plastic or a metallic specimen, compared to a CHAPI impact testing that we use mainly for a metals specimen only. And here we have some characteristic of a CHAPI impact testing versus isotope impact testing in terms of a material tested. For CHAPI impact testing, like what I have mentioned before, mainly cater for metal specimen. Isotope impact testing, we can apply it for for plastic and metals. Types of notches for CHAPI impact testing. The types of notches can be in a U notch or V notch. And for isotope impact testing, we can use only a V notch only. In terms of the position of the specimen, for CHAPI impact testing, the specimen is horizontally notch facing away from the pendulum. On the other hand, for isotope impact testing, the position of the specimen is vertically notch facing toward the pendulum. And the striking point of CHAPI impact testing is in the middle of the sample. And for isotope impact testing, the striking point is at the upper tip of the sample. Common dimension of specimens for CHAPI impact testing is 55 times 10 times 10 millimeters for a CHAPI impact testing. For isotope impact testing, for a plastic specimen, the typical dimension is 64 times 12.7 times 3.2 millimeter. Or for metal, is at 127 times 11.43 round bar. And a common specification for CHAPI impact testing is STM E23 ISO 148 EN 100451 for CHAPI impact testing, and specification for isotope impact testing is STM D256, STM E23, and ISO 180. So this is the common impact testing value for selected alloy. So when we report the results of CHAPI impact testing, the absorbed energy in joule is always reported, while the percentage crystallinity and lateral expansion are optional on the test report. So this is optional, and the absorbed energy is always reported. It should be emphasized that CHAPI testing are qualitative. The results can only be compared with each other or with a requirement in a specification. They can be used to calculate the fracture toughness of a welding or origin or parent metal. So what does it mean by a lateral expansion? Lateral expansion is a measure of the ductility of the specimen. Ductility. When a ductile metal is broken, the test piece deforms before breaking, and a material is squeezed out on the side of the compression phase. The amount by which the specimen deform in this way is measured and expressed as millimeters of lateral expansion.